Hello friends, welcome to my lecture, second lecture on correlation and regression. The correlation coefficient is independent of the change of origin and scale. We shall prove this result. So, let us say let us define the random variable u as x minus a by h and the random variable v as by minus b over k, where x and y are any two random variables. A, b, h, k are real numbers here, h and k are positive real numbers. Okay. We wish to show that the coefficient of correlation of x by is same as the coefficient of correlation of u b. That means, it is unaffected by the change of origin, okay, and the scale. So, from x equal to from u equal to x minus a by h, okay, we find x equal to a plus h u, and from v equal to y minus b over k, we find that the random variable y is equal to b plus k b. Hence, the mean of x, that is expectation of x, is equal to expectation of a plus h u, and so it is a times expectation of 1, expectation of 1 is 1. So, we have a plus h times expectation of u, that is mu u. Similarly, expectation of by mu y is equal to E y equal to expectation of b plus k v, which is b times expectation of 1, which is 1. So, b plus k times expectation of b, that is mu v. Okay. So, we get mu y equal to v plus k times mu v. Now, covariance of x y. Covariance of x y by definition is expectation of x minus mu x into y minus mu y. X is equal to a plus h u, mu x we have just now seen is a plus h mu u. Okay. So, we put the value of mu x here, and y is equal to b plus k b, mu y is b plus k into mu b. So, let us put their values of mu x and mu y. What we get here, this a will cancel with this a, b cancels with this b, and what we get, h times u minus mu u, k times b minus mu b. Okay. So, expectation of h k times u minus mu u into b minus mu b. H k is a constant, so it will come out, and we get h k times covariance of u b. Okay. Now, sigma x square is expectation of x minus mu x whole square. X is equal to a plus h u, mu x equal to a plus h into mu u. So, this a and this a cancel, and we get expectation of h square times u minus mu u whole square. So, this is h square times expectation of u minus mu u whole square, and similarly sigma y square is expectation of y minus mu y whole square, which is equal to k square into expectation of b minus mu v whole square. Okay, this b cancels. So, this gives you k square times expectation of b minus mu b whole square. Now, rho x by definition is covariance of x y divided by sigma x sigma y. Covariance of x y is h k into covariance of u v, and sigma x square is equal to h square times expectation of u minus mu u whole square. So, sigma x equal to h times sigma u. Okay. And here sigma y square is equal to k square times sigma b square. So, sigma y equal to k times sigma b. Okay. So, we put their values. So, sigma x equal to h sigma u, sigma y equal to k sigma b. So, this h k cancels with h k here, and we get covariance of u b divided by sigma u sigma b. So, covariance of x y is same as, so rho x by is same as rho u v, that is the coefficient of correlation is not affected by the change of origin and scale. Now, let us find the angle between the two regression lines, the regression line of y on x and the regression line of x on y. It be if the theta is the acute angle between the regression line of y on x and the regression line of x on y, then theta is given by tan inverse 1 minus rho square by rho sigma x sigma y over sigma x square sigma y square, where rho is the coefficient of correlation between x and y. Now, the line of regression of y on x we know is given by y minus mu y equal to rho sigma y over sigma x, x minus mu x. So, here slope of this regression line of y on x is rho sigma y over sigma x, which we denote by m1, and similarly the slope of the regression line of x on y we can find. The regression line of x on y is given by x minus mu x equal to rho times sigma x over sigma y into y minus mu y, and this can be written as y minus mu y equal to sigma y divided by rho sigma x into x minus mu x. Okay. So, here m2, the slope of this regression line of x on y is equal to sigma y divided by rho times sigma x. Okay. So, m1 is rho sigma y over sigma x, m2 is sigma y over rho sigma x. Okay. So, this is m2. Now, theta is given by tan inverse m1 minus m2. Now, this symbol means we consider the difference m1 minus m2 if m1 is greater than m2, and we consider the difference m2 minus m1 if m2 is bigger than m1. So, that means we will always consider the positive sign here. Okay. So, tan theta equal to m1 minus m2 or m2 minus m1 divided by 1 plus m1 m2. You put the values of m1 and m2 here. Okay. What we get? It simplifies to this rho. Now, here rho is mod of rho is less than 1, less than or equal to 1. So, we shall write it as 1 by rho minus rho. Okay. This will be written as 1 by rho minus rho sigma y sigma x divided by sigma x square plus sigma y square, and this gives you 1 minus rho square divided by rho sigma x sigma y divided by sigma x square plus sigma y square. So, theta is equal to tan inverse 1 minus rho square divided by rho into sigma x sigma y divided by sigma x square plus sigma y square. Now, from here we can see if the random variable x and y are uncorrelated, that is rho equal to 0, then theta is equal to pi by 2. Tan inverse infinity is pi by 2. So, that means the regression line of y on x and the regression line of x on y will be perpendicular to each other. So, when x and y are uncorrelated, rho is equal to 0, that is the two regression lines are perpendicular to each other. When x and y are perfectly correlated, that is rho equal to plus minus 1, what we get here 1 minus rho square becomes 0. So, theta is equal to 0, that is the two regression lines coincide. Now, let us do this problem. The tangent of the angle between the lines of regression of y on x and x on y is 0.6. Okay. So, here tan theta equal to 0.6. Okay. So, tan theta equal to 1 minus rho square divided by rho sigma x sigma y over sigma x square plus sigma y square gives you 1 minus rho square divided by rho into sigma x is equal to half sigma y. So, half sigma y square and divided by 1 by 4 sigma y square plus sigma y square, and this is equal to this gives you tan theta is 0.6. So, 0.6 equal to 1 minus rho square divided by rho, and here we get 1 by 2 into 4 by 5. Okay. So, this implies 1 minus rho square divided by rho equal to 6 by 4. Okay. So, 3 by 2. So, we get 2 minus 2 rho square equal to 3 rho, which implies 2 rho square plus 3 rho minus 2 equal to 0, and this can be written as 2 rho square plus 4 rho minus 2 equal to 0. So, we get 2 rho times rho plus 2 minus 1 times rho plus 2. So, we get the two roots as rho equal to half and minus 2. Okay. Now, since rho is bounded by 1, okay, mod of rho is less than or equal to 1. So, rho equal to minus 2 not possible. and hence rho must be equal to half. Okay. So, the value of rho is half. Okay. Now, let us take another example. If y equal to 2x minus 3 and y equal to 5x plus 7 are the two regression lines, find the mean values of x and y, the correlation coefficient between x and y, find an estimate of x when y equal to 1. Okay. Now, sometimes we are given the problem where we do not know which one is the regression line of y on x and which one is the regression line of x and y. So, we can choose any line as the regression line of y on x, then the other will be regression line of x on y, and then we shall find the rho from there. Okay. If the value, if we shall find the beta x y and beta by x, the product of beta x y beta by x should be is equal to rho square, and rho is less than or equal to 1. So, if rho is square is less than or equal to 1 we get, then our choice is correct. If rho square comes out to be greater than 1, then we will have to our assumption is wrong. So, we will have to then take the other line as the regression line of y on x and vice versa. So, we will change the choice of regression line of y on x. So, here we are not told which one is the regression line of y on x and which one is the regression line of x on y. So, let us assume that y equal to 2x minus 3 is the regression line of y on x. And y equal to 5x plus 7, or we can say x equal to y minus 7 by 5, that is to say 1 by 5 times y minus 7 is the regression line of x on y. Okay. Then beta x y is the regression coefficient of y on x. Okay. So, this will be equal to 2. Okay. Y is equal to 2 times, I can write it as 2 times x minus 3y2. Okay. So, this 2 gives me beta x y, and similarly beta y x. Oh, no, this is the regression coefficient of y on x. So, I will write it as beta y x. Okay. Beta y x is 2 and beta x y. Okay. X minus x var, x minus mu x equal to beta x y into y minus mu y. Okay. So, 1 by 5 is beta x y. Okay. So, now we know that beta y x into beta x y is equal to rho square. Okay. So, here what do we get? 2 into 1 by 5. So, this is 2 into 1 by 5, okay, which is less than 1. Okay. So, our choice is correct. Okay. So, this is a regression line of y on x, this is a regression line of x on y, and this also gives me the value of rho. Rho is equal to square root 2 by 5. Okay. So, this is the value of rho. Rho is equal to square root 2 over 5. Now, let us find the mean values of x and y. Okay. So, mean values of x and y, mu x we have to determine. Okay. We know that the two regression lines both pass through the point mu x mu y. Okay. So, mu x mu y. So, mu y equal to 2 mu x minus 3 and mu y equal to 5 mu x plus 7. Okay. So, this will give you what? Let us solving these two equations, what we will have? 5 mu x plus 7 equal to 2 mu x minus 3. Okay. So, this will give you 3 mu x equal to 10. Okay. This will become 3 mu x equal to 10. Okay. So, this gives me mu x equal to 10 by 3. Okay. And mu y is then what will be mu y? Mu y equal to 2 mu x. So, 2 into 10 by 3 minus 3. This comes out to be 20 by 3 minus 3. So, 20 minus 9, 11 by 3. What is wrong? Oh, okay. Let me do it again. We have to take rho to be, now see, we have to take beta by x. Okay, this is square root 2 by 5. Square root 2 by 5 is 0.6325. Okay, this was plus minus 0.6325. Okay. Now, our problem is whether we should take positive sign or negative sign. Okay. So, beta by x is equal to beta by x when written in terms of rho. What is the formula for that? Beta by x is equal to beta by x equal to sigma rho sigma by over sigma x. Okay. Yeah, rho sigma by over sigma x, rho sigma by over sigma x. Okay. And so, here since beta by x is equal to 2, okay, so rho must be positive. Okay. Beta x by also, beta x by is equal to rho times sigma x over sigma y. Okay. And this is the given to be equal to beta by x is given to be 2. Okay. Beta x by is given to be 1 by 5. Okay. So, since beta x by and beta by x are both positive, so rho must be positive, and therefore, we take the value of rho as 0.6325. Okay. We choose the sign as positive because beta by x and beta x by are positive. Okay. Now, we know that the two regression lines pass through mu x mu y. So, this gives you mu y equal to 2 mu x minus 3, and here mu y equal to 5 x mu x plus 7. So, 5 mu x plus 7 is 2 mu x minus 3, 5 mu x plus 7 equal to 2 mu x minus 3. So, 3 mu x equal to minus 10. This is minus 10 here, minus 10 here. So, mu x equal to minus 10 by 3. Okay. So, mu x equal to minus 10 by 3 and mu y equal to 2 into minus 10 by 3 equal to minus 20 by 3 minus 3. So, that gives me minus 29 by 3. Okay. So, this is mu y. Now, let us find an estimate of x when y is equal to 1. So, we have to find an estimate of x when y is given. That means, we use the regression line of x on y. Regression line of x on y is this. Okay. Y equal to 5 x plus 7. So, when y is equal to 1, okay, we have y equal to 1 equal to 5 x plus 7. So, x equal to minus 6 by 5. Okay. So, we get x equal to minus 6 by 5. The value of x when y is given is found from the regression line of x on y. Now, let me go to another question. Two random variables x and y are defined as y equal to 4 x plus 9. Find the coefficient of correlation between x and y. Okay. So, coefficient of correlation y equal to 4 x plus 9. Okay. So, let us first find expected value of y. Okay. Expected value of y is mu y. So, this is equal to expected value of 4 x plus 9. Okay. So, this is equal to 4 times expected value of x, that is mu x, plus expected value of 9, which is 9. Okay. So, expected value of y is 4 mu x plus 9. Okay. Variance of y I get. Okay. Let me write directly the variance of y. So, variance of y. Okay. Variance of y is expectation of y minus mu y whole square. Okay. So, expectation of y is equal to 4x plus 9, okay, minus mu y equal to 4 mu x plus 9. So, we get this. Okay. So, we cancel this, will cancel with this, and we get 4 square. 4 square means 16. So, 16 times variance of expectation of x minus mu x whole square. So, 16 times variance of x. Thus, we get mu y equal to 4 times mu x plus 9, or variance of y equal to this. So, this implies sigma y equal to 4 times sigma x. Okay. Now, expectation of we need to find covariance. So, expectation of x y. So, expectation of x y is expectation of x into 4x plus 9. So, this is 4 times expectation of x square. So, expectation of 4x square plus 9x. So, this is 4 times expectation of x square minus plus 9 times mu x. Okay. Now, rho is equal to EXY minus EX EY divided by rho x sigma y. Okay. So, EXY is 4 EX square plus 9 mu x minus expectation of EX, expectation of x into expectation of y is equal to 4 times mu x plus 9. 4 times expectation of x we can write as mu x. So, this is mu x, okay, and then I get here 4 times mu x plus 9, okay, divided by sigma x, and sigma y is 4 sigma x. Okay. Now, what is this? So, 9 mu x will cancel with 9 mu x. What we get here, this is equal to 4 times E x square minus mu x whole square. So, we get variance of x, that is 4 times sigma x square. Okay. 9 mu x cancel, and we get here 4 by sigma x square. So, this cancels with this and this cancels with this, and we get 1. Okay. So, rho equal to 1. Now, let us take the last problem. From the given data, find the two regression equations, regression line of y on x and regression line of x on y. The coefficient of correlation between the marks in economics and statistics are given in this table. The most likely marks in statistics when the marks in economics are 30. Okay. So, let us say we are given x and y. Okay. X is 25, okay, 28, 35, we have 32, okay, 31, 36, then we have 29, 38, okay, 34 and 32, okay, and y values are 43, 46, 49, 41, 36, 32, 31, 30, 33, 39. Okay. Let us since the coefficient of correlation is independent, I mean it does not get change with the change in origin and scale, let us choose let us shift the origin. So, let me write here xi equal to say x minus 31, okay, and y equal to eta equal to y minus 41. Okay. So, if we do that, then xi is equal to, so we are subtracting 31 here. So, minus 6, okay. This will be minus 31 means minus 3, 31 we subtract from 35 we get 4, 31 we subtract here we get 1, here we get 0, here we get 31 subtract 10 gives 5, here we get minus 2, here we get 7, here we get 3, here we get 1, okay. And eta will be when we are subtracting 41. So, 2 and then here 5, here we get 8, here we get 0, okay. Here we get minus 5, here we get minus 9, here we get minus 10, here we get minus 11, here we get minus 8 and here we get minus 2, okay. So, what is sigma xi? Let us find. So, minus 6 minus 3 minus 9 plus 4 minus 5 plus 1 minus 4 minus 4 plus 5 plus 1 minus 2 is minus 1 plus 7 is plus 6 and 3 9 and 1 10. So, sigma xi is 10, sigma eta is equal to 2 plus 5 7, 7 and 8 15, 15 minus 5 is 10, 10 minus 9 is 1, 1 minus 10 is minus 9, minus 9 minus 11 minus 20, minus 20 minus 8 minus 28 minus 2 minus 30. So, we get minus 30, okay. Now, then we need to get xi eta, okay. So, minus 6 into 2 is minus 12, then minus 3 into 5 is minus 15, then we get 4 into 8 32, okay. We get 1 into 0 0, 0 into minus 5 0, 5 into minus 5 minus 45, minus 2 into 10 minus 10 plus 20, 7 into minus 11 minus 77, and then we get 3 into minus 8 minus 24, then 1 into minus 2 is minus 2, okay. We also need to find xi square, okay. So, xi square is 36, okay. Then we have minus 3 square is 9, 4 square is 16, 1 square is 1, 0 square 0, then we have 25, then we have 4, then we have 49, and then we have here 39, and then we have 1, okay. And we need to find eta square. So, 4, then we have 25, then we have 64, then we have 0, we have 25, we have 81, okay. Minus 9 square, minus 10 square is 100, and then we get 121, and then we get here 64, and here we get 4, okay. Now, what is sigma xi square? Okay, sigma xi square is 36 plus 9 45, 45 plus 16, 45 plus 16 is 61, okay. So, we get 61, then 162, 62 plus 25, 62 plus 25 means 87, okay. 87 plus 4 91, 91 plus 49. So, we get here 140, 140 then 10 150. So, we get 150 here, and sigma eta square we can find, okay. So, this is 4 plus 25 29, 29 plus 64. So, we get here 93, 93 plus 25, we get here 118, 118 plus 81, we get here 199, okay. Then 100. So, we get 299, okay, 299, and then we need to add 121 64 4, 121 plus 64 plus 4 68 we add here. So, this gives me 189, okay. So, 189. So, 189 we add to 299, okay. So, 299 we add, okay. This comes out 488, okay. So, we have the values here. Now, sigma xi eta also we have to find. So, we have here minus 12 minus 15 minus 27 minus 27 plus 32 plus 5 minus 45 minus 40 plus 20, minus 20 minus 20 minus 77 minus 97 minus 97 minus 24, and also we have minus 2. So, 123. Okay. So, minus 123. Okay. Now, let us find first we find mu x. Okay. Mu x equal to assumed mean, okay, A plus sigma xi over n. A is the assumed mean. Assumed mean is equal to 31. Okay. So, 31 and sigma xi equal to 10, 10 by 10, because there are 10 values. Okay. So, this is 32, and mu y equal to assumed mean is 41 here. So, b plus sigma eta divided by n. Okay. The b is equal to 41 and sigma eta is equal to minus 30. So, minus 30 divided by 10. So, this is minus 3, that means 38. Okay. Then we need to find variance sigma x, sigma y. So, sigma x, okay, sigma x is given by square root sigma xi square divided by n minus sigma xi by n whole square. Okay. So, this is square root sigma xi square 150 by 10 minus sigma xi is equal to 10, 10 divided by 10 whole square. So, this is square root 15 minus 1, that is 14. Okay. And sigma y similarly is equal to square root sigma eta square divided by n minus sigma eta divided by n whole square. Okay. So, this sigma y is equal to then sigma eta square 488. So, 488 divided by 10, that means 48 by 48.8 minus sigma eta is minus 30 divided by minus 3, oh sorry, minus 30 divided by 10, minus 30 divided by 10 whole square. So, this is square root 48.8 minus 9. Okay. So, this is square root 39.8. Okay. So, this is the value of sigma y. Okay. Now, we have to find the two regression equations. We have the value of mu x, mu y. Okay. So, we need to find the value of coefficient of correlation also we need to find, and the two regression lines are given by beta by x and beta x by. Okay. So, we need to find, okay, so E x y, okay, the covariance also we can find, covariance of xi eta. Okay. So, covariance of x y, this is also equal to sigma xi eta by n minus sigma xi by n into sigma eta by n. Okay. So, this comes out to be covariance of x y sigma xi eta by n. Sigma xi eta is minus 123 divided by 10, okay, minus sigma xi by n. Sigma xi by n is 10 by 10, that is 1, okay, and sigma eta by n is minus 30 by 10. So, what we get, this cancels and this cancels and we get plus 3. So, here minus 123 minus 12.3, minus 12.3 and plus 3. So, how much we get? Minus 9.3, okay, minus 9.3, that is covariance of x y divided by sigma x, sigma y. Okay. So, we need to find covariance of sigma rho is equal to covariance of x y divided by sigma x, sigma y. So, minus 9.3 divided by sigma x, sigma y. Sigma x is equal to root 14, sigma y is equal to root 39.8. So, root 14 and root 39.8. Okay. it comes out to be equal to rho equal to minus 0.3940. So, minus 0.3940. So, this is rho. Okay. Now, the regression line of y on x is given by y minus mu y rho sigma y over sigma x into x minus mu x. Okay. So, y minus mu y we have found mu y equal to 38, okay, and mu x is 32. Okay. So, 38 rho we have found rho is equal to minus 0.3940. Okay. And what is sigma y and sigma x? Sigma y is equal to this one root 39.8, okay, and sigma x is root 14. So, root 39.8 divided by root 14, and x minus mu x is 32, okay, this mu x 32. So, this is the regression line of y on x and regression line of x on y. Is given by x minus mu x equal to sigma rho sigma x over sigma y, sigma x over sigma y, y minus mu y. Okay. So, we have x minus mu x is 32, okay. This should be small x, equal to rho is minus 0.3940 into sigma x is square root 14 divided by square root 39.8, okay, into y minus mu y, which is 38. So, these two are the regression lines of y on x and x on y. Okay. The most likely marks in statistics when the marks in economics are 30. Okay. So, marks in economics we have denoted by the random variable x, and marks in statistics we have denoted by the random variable y. We want to find the most likely marks in statistics, that means we want to find the likely marks in y when the marks in x are given. So, they can be found from the regression line of y on x, okay, because the value of y is to be found when the value of x is given. So, regression line of y on x is this one, okay. This is the regression line of y on x. In this you put x equal to 30, okay. So, you get the value of the likely marks in statistics. X when you put as 30, y will come out to be minus 0.6643 into 30 plus 59.2570, which will be equal to 39.3286. So, that is how we solve this problem. With that, I would like to end my lecture. Thank you very much for your attention.